welcome to the final Astro Cafe until we're, I guess, restarting in September on the 9th, I think. So this will be it until then. But we've got a few people that have some interesting stuff. Sherry has put together some stuff about the Aurora, and David Lee has some stuff about the International Astronomy Day and some information about his SIGs. So is it, before we get diving into it, is there anybody else who has anything that they want to speak to? I know there was a note about Bill Weir as well. Is Bill on yet? I don't see Bill. Okay. Well, why don't we let Sherry dive in and tell us about Aurora and solar activity.
All right. So who is a real rookie with Auroras? Because we can do this two ways. I can either run the PowerPoint thing, which is kind of made for everybody. And it's a bit probably tedious at the beginning if you sort of already know about this stuff. So I can skip ahead to the good stuff, or we can just start at the beginning and work through it.
Start at the beginning, Sherry. I saw your slides. They're good.
You want to start at the beginning?
Oh, yeah.
All right. Let's see if I remember how to do this.
It's working.
Just bring that over there. That's yeah, there. And then click on the 3x3 icon, the one, yeah, that one, and then just drag out the corner.
Are we seeing anything yet?
We just see the name of the file. I think you got to double click on the name of the file. And that's your old version. That's your 2013 version.
Yeah, that's the one I've got.
Oh, okay.
Okay.
No, it didn't work.
It worked when we tried it before.
It sure did.
All right.
So now it's showtime, so it's gonna be a pain in the neck.
Yeah. So,
It's down below at the bottom.
PowerPoint. Click on PowerPoint there.
Why wouldn't you click on one of the files?
Or click on the file name. That's right. Click on the file name itself.
Didn't get to it quick enough.
How do you normally look at? Oh, there you go. You got it.
Got it now? Yeah, there we go.
Now you just have to start your presentation.
Slideshow, right on.
How's that?
And this is Sherry's first time presenting on Zoom.
What's that?
I'm just telling everybody it's your first time, so this is excellent.
Okay, can you see it now?
Yes. Perfect.
All right. So I'll just scroll through them one at a time until we get to the good stuff. And if you need to know something, just I'll stop, okay? So can you read all that okay?
No, you gotta talk.
What's that?
You have to tell us about it.
Okay, so I think everybody knows that we go through like an 11-year sunspot cycle, but there's actually 2 solar cycles. We know about the 11-year one, but that's when the polarity flips from positive to negative around some of the sunspots. But the other is a 22-year magnetic solar cycle where they flip back again. And then by measuring the polarity of the sunspots, we actually know when one solar cycle ends and the next one begins. And for those who don't know, sunspots are basically magnetically contained storms on the surface of the sun. And for the most part, the storm is contained by magnetic containment, like a fence or whatever you might want to call it, so they're kind of contained. But when the pressure of the storm, of the sunspot storm, builds to such a point that the magnetic sort of fence or containment can no longer contain it, then it blows off the surface of the sun in what we call a coronal mass ejection. And so that basically just blows a great chunk of the solar surface right into space. So CME is what we use for short. If you see my little blurbs on Facebook about CMEs, that's what it means, coronal mass ejection. And the other way that we get potentially northern lights is a coronal hole, which is actually like basically a rift in the surface of the sun and the sun's corona. And so when you get a coronal mass ejection, when it blows off the sun, it's like an immediate event. And so the explosion happens, it hurls chunks of the solar surface into space. And if it hits the Earth, it results in impact. With the coronal hole, what happens is it's actually blowing out chunks of the surface of the sun all the time. And as it rotates geo-effectively, in other words, when the sun rotates and the coronal hole begins to align with Earth, then we get the same effect at the Earth. So we get the increased solar wind speed, density, proton density. But instead of like a serious impact, it sort of builds slowly to a peak, and then it tapers off as the sun sort of rotates away. The effect on Earth can be the same. We can end up with really good auroras, geomagnetic storms from it, rather than an actual impact, like a real punch. This builds slowly and then tapers off. So basically, this just explains a little bit about, what the northern and southern lights are and the different colors. So green is oxygen up to 150 miles, red is oxygen above 150 miles, blue nitrogen up to 60, and purple nitrogen above 60. Whoops. And there's a shot from 2003 or something, kind of showing the red is in the upper part, the green is lower. And if you notice, a lot of the photographs from this latest storm and other big storms, places like Texas and California and whatever, most of them only show red on the horizon. They very rarely do they ever get to see the greens and blues and purples. And the reason for that, of course, is that the red is much higher in the atmosphere. Everything below that, the green, is sort of hidden by their horizon. They're only seeing what kind of rises above their horizon further south. So most of what they see are the red auroras, because everything else is kind of hidden, kind of below the Earth's curvature. Unless we get really big superstorms like last one, when they can actually have color too. But for the most part, the southern US and places like that only see the tops of the aurora.
I love that you can see the Big Dipper in that picture.
Oh yeah. It's kind of cool, isn't it? So basically, whether it's a coronal mass ejection or whether it's a coronal hole, when the wind stream reaches Earth, it basically is trapped by our magnetic field lines and spirals down into the south and north magnetic poles. And you can see what we call the aurora oval right up there. So the north magnetic pole is right in the center of that aurora oval at the top, and the same thing down at the south. So we'll concern ourselves with the coronal mass ejections. And as you probably know, they're initiated by a solar flare, and we have several categories of solar flares. We don't often talk about A, B, or C because they're pretty minor. M and X are the ones that we really concern ourselves with, and with each category is 0 to 9. And I'll show you later on, after this is over, how these all kind of interact with each other. But the geomagnetic storms or aurora storms are G1 through 5, 5 being the strongest. And they also correspond with the KP, which is the planetary KP value, which is the strength of the storm. So G1 is fairly weak. I usually send out an alert for a G1 storm, but we're so far south that we rarely see G1 storms. And G1 correlates with KP5, and so on. It goes up the scale. And when there's a big flare, whether it's M or X, there's also usually a pretty wicked solar radiation storm that occurs at the speed of light, basically from the sun to the earth. And it can black out shortwave radio. It can mess with telecommunications, aircraft navigation, all that stuff. So we have to be really careful about paying attention to these things. And we're a little closer to the north magnetic pole than we are to the north geographic pole, in that we're 48.5 north geographically, but we're actually 53 degrees north geomagnetically. But that's getting bigger every year because the north magnetic pole is migrating slowly over the top of the world towards Russia. And so why do we think it's important? Well, we go back to 1989, the great Quebec blackout storm. I mean, a big chunk of Quebec and down into the northeastern US was blacked out. Massive damage to power supplies, things like that. In 1927, something like that, there was something called the Great New York Railway Fire, which actually caused a train station in New York State somewhere to burst into flames. There's so much power coming down into our atmosphere that things like communication lines, like hydro lines, power lines, even steel pipes in the ground can pick up this intense power from the sun and transmit it down to things like substations and where power lines meet, and cause all kinds of damage. Now, notice the recent storm 2 or 3 weeks ago didn't do that. Starting in 1989, they really started to take these things seriously by hardening satellites, being able to turn satellites around with a shield on the back side so they can block the radiation, and just being able to harden electronics against these kind of things. We're not out of the woods yet, but we're doing a lot better than in 1989. That was a bad one. And so this last one, I think we learned a lot, but it can have long-term consequences on all kinds of electronics. And basically nowadays, everything we do is electronic, and a lot of it involves satellites. So we need to really be aware of the power of these things and make sure that we're not left pretty much stranded by massive infrastructure shut down. So rather than it's not just pretty lights that we get to photograph in the sky, there's some real potential dangers by not being prepared for some of these things. So, whoops. So what is out in space that actually shows us all this information? SOHO and the camera LASCO are parked at the Lagrange point, and are constantly monitoring the sun in a whole bunch of different wavelengths. And I'll show you a picture later on, but that actually gives us the initial data on, say, a coronal mass ejection. So it'll actually photograph the impact going away from the sun, and it'll sort of measure the direction and the initial strength and the speed of it, which kind of gives us an initial, a kind of preliminary sort of estimate on what the CME is going to do, whether it's headed towards us, a little bit off center, away from us, how strong it might be, if it's going to be a direct hit, about how long it might take to get here, and then we can sort of prepare for these things. So and there's us and the sun and various instruments parked around, always monitoring the sun. And ACE is another one. We'll come to ACE in a moment. So there's actually an image of a coronal mass ejection right there, captured by LASCO on the camera on SOHO. And you can actually see that's actual all that white billowy stuff is actually chunks of the surface of the sun. I mean, that's a coronal mass ejection right there. Just as it's leaving the sun, the camera actually has a little occluding disc or occulting disc right in the middle, so we can actually see the corona better. So that one's not headed directly at us. You can see it's sort of a bit off center down to the southwest. But that was a big one, and that chunk of that one would probably hit the Earth. So even if it doesn't hit us directly on, if it's strong enough, even just clipping us a little bit can cause some fairly major auroras. So that's actually what a CME looks like leaving the sun. So ACE is the satellite that we use most for measuring. So anywhere from 24 to 30 or so hours, up to about 48 hours it takes for a CME to reach Earth after it leaves the sun. And so once it leaves the sun, we kind of have our preliminary data about which way it's going and how strong it's going to be. Then we all just kind of sit and wait. We have no idea. There's models that NASA and NOAA run. Sometimes they agree, sometimes they're wildly diametrically opposed. But basically, all of us just sit and wait. And then at the appointed time, give or take a few hours, the CME will pass ACE. So Advanced Composition Explorer, and that gives us all the information that we need to know to get ready. And usually between ACE and the Earth, it's 30 minutes to an hour and a half before the CME actually impacts the Earth. So, SOHO sees the CME leaving the sun, gives us some preliminary information. Then we all kind of sit around and wait, and they run their models and try and figure out exactly when it's going to come. Sometimes it works, sometimes it doesn't, sometimes they miss it completely. But when it arrives, it usually hits ACE first. And then that gives us our information about what's going to happen next. And so there's a typical ACE. There's a typical ACE graph. So the one, and this, if there's one resource that you need to watch all the time, it's this one right here. This gives us everything we need to know. So starting at the top, this, if you look at the left here, there's BT and BZ, properly pronounced B sub T and B sub Z, but that's a mouthful. So BT is the total strength of the incoming CME, the magnetic field in the CME. It's a total strength. That's the white line up above here. And the BZ is the northward or southward component of this chaotic tangle of magnetic fields in the wake of the CME, and that's the red line down here. And then the next one is the density. So normal background proton density is like 1 proton per cubic centimeter or so, normal solar background wind. And it kind of fluctuates and it's up and down a bit. So what we're going to see, and the next slide will show it, but what we want to see is that to jump up as high as it can go. And the solar wind speed, normal background solar wind speed is about 300, 350 kilometers per second. And we want to see a big rise in that too. And the temperature is actually the physical temperature of the protons and electrons coming through. So here's where we see an impact. You see what happens right there? So we have our normal background, total solar wind strength, and the background, or the total northward or southward component of it. And right there, just about 20, 21, 15 hours on the bottom there, you'll see an impact. And you see the solar wind suddenly jump up, which is good. We want to see it rise at least to around 10 or more. And the solar wind speed takes a fairly moderate jump, but at least it's a jump. It goes up to about 400 or so there. So that's what an impact looks like right there. Oops. So this actually is good. You see the way, I'll explain the north-south of the BZ in just a minute here. But that's good. You want to see the red line, you want to see it drop down as far as it can go and stay there as long as it can go. If it bounces up and down, it tends to lead to short, choppy little auroras and not very much of anything. So you want to see that BZ go down to -10, -20 and stay there for a long time. So this one is actually pretty good. This one's not so good. So this is actually an impact, but look where the red line is at the top there. It's gone north of that dotted center line. That is not good. That means that the interplanetary magnetic field contained in the wake of this CME has rotated northward, and that tends to shut down auroras completely. You almost never see auroras when that red line is above. Even though that the BT is really strong at over 10, that red line is the key to almost everything. So if the total strength, the BT is good, and even if the density is really good and the solar wind speed is really good, if that red line goes north of that dotted line and stays north for any reasonable length of time, chance of auroras are almost zero. And of course, conversely, you can have a fairly weak density and a fairly weak speed. But if that red line, the BT or the BZ, drops down below that dotted center line, you can even have some great auroras if everything else is sort of moderate. As long as that red line stays below that dotted line, especially further south, and as long as possible. So it's just a bit of a recap. So the BT is a total interplanetary, or IMF, interplanetary magnetic field strength. It's measured in nanoteslas, I believe. BZ is the north-south orientation. I'll do that in a sec. Density is protons per cubic centimeter. Normal is about 1 to 3. I mean, a good one is 10 or more protons per cubic centimeter, and sometimes it goes much, much higher. And solar wind speed is just the actual speed of the wind coming through. Sometimes these coronal mass ejections can be big, pokey, slow ones with a long wake that last for, you know, many hours, even a day or two, and some of them are really short, fast, and sweet, and they hit and they're just gone. So all those kind of interact with each other, but that BZ, the red line, is the key to everything. If it's north, it's just about almost guaranteed we're not going to see auroras. If it drops south, then the chances are pretty good. And so this is just a bunch of magnetometers in Canada that measure this stuff. There's also down in the States and all over the world as well. And we've all probably seen the green aurora oval on different websites and things. This is from the Space Weather Prediction Center at NOAA. And of course, that green oval tends to expand and turn red as the aurora gets stronger and moves further south. That aurora gets bigger. So the further south you can see it is kind of a graphic representation of about where you might be able to see auroras. And I'll go into this one. This is the Canadian one. This is Space Weather Canada. And I'll bring up their webpage too in a bit. So this kind of shows the three zones. There's the polar zone, the aurora zone, and then the sub-aurora zone here. And these circles will change color depending. You see on the graph here: major storm, stormy, active, unsettled, and quiet. And those three bands will change colors. They're pretty accurate. They actually do a pretty good job. Space Weather Canada does actually a really good job at keeping up and updating it in real time quite quickly. And when there's major storms, you'll see there'll be purple lines streaked through whichever zone is expecting a major storm watch. And it has current conditions, 6-hour forecast, 24-hour forecast, and also has previous day conditions on it as well. I'll show you that in a bit. This one I always should have removed because I don't use this one anymore. So this is the KP, the planetary KP index. And so, I mean, normal is down in the green. If you look at the green bars down below, that's sort of normal background, no solar wind, no solar activity going on. But when a storm hits, this measures, it's a different graph. It shows the total strength of the geomagnetic conditions at the time. So it's not just a measure of the magnetic fields or the speed or the density. It's kind of a combination of everything. And when a storm kicks off, this is actually a measurement of the strength of the storm. So the yellow is usually around KP 4 or 5. So I don't usually send out an alert until it gets up to about 5. 5 is tricky. 5 is the minimum we can see here on a really, really good clear night. And even then, we only see auroras maybe low over the mainland. We don't see it very much at the beach with a good clear view to the North Shore Mountains over Vancouver or the Sunshine Coast. You'd probably see some light auroras, just very low. But when it gets way up here to 6, that's when we take interest in Victoria and the South Island. That's when we start to see the good storms. And you see it to the right, this one actually went up to 7, which is a major storm level right there. And that's pretty close to what we saw the other night, a couple weeks ago. It was like 7, 8, 9 that time. So 7 is really good. 6 is pretty good. 5, maybe a little bit. And I thought I removed that one because we don't use that one anymore either. So, and this is the solar sunspot cycle for the last solar cycle, which was solar cycle 24, which peaked in about 2013, 2014. And I've got an updated one for the current solar cycle coming up next or very soon. So just a kind of a recap, what I do is I signed up for email alerts from the Space Weather Prediction Center at NOAA, and you can do it too, and they'll send you storm time alerts, what's coming up at us when there's actually active space weather. They also send out, I think it's weekly, sort of recaps of what's going on with the sun. So I just wait for those, I watch those, and I watch spaceweather.com, and I just sort of see what they're saying, and they've got some data down the left side of the screen. So I just kind of monitor stuff every couple of days during the quiet times and several times a day when it's really active times. So spaceweather.com is a good one for just like a lay person who wants to just kind of be aware of what's coming and sort of be ready for it. The downside is they don't tend to update their text forecast as often as I'd like, but all the data on the left side of the screen, which I'll show you in a bit, is pretty accurate. So you just watch, you get your email alerts, you just kind of watch, just keep aware of what's going on, especially when things start to ramp up. And then you just go to start monitoring ACE. That ACE graph, you can actually go you can just Google ACE mag SWEPM, and you can go directly to that page and just watch that only. And so you just watch that, and I just kind of keep sort of just aware of what's going on. And closer storm time comes, and I start to really monitor these pages and graphs and stuff. And especially that red line, that BZ, that's the key right there. Again, if that goes nice and south, that's when you grab your cameras and you head out. And if it heads north, then that's when you crack your favorite beverage and sit home and watch a movie. But the problem with these things is that the ACE satellite can measure these things, but it's a momentary thing. Like it only measures what's happening at the moment at the spacecraft. There's no way of telling what's coming next. So these things either have a little short wake, like CME will have like a short little wake, and it hits and it's a punch and off it goes and it's done. Or sometimes these things can have a wake that stretches almost back to the sun and can take a day or more to go past us. So we know what's happening at the moment at the ACE satellite, but we don't really know what's coming, 30 minutes down the road or an hour down the road. So it's one of those things that you just have, like once the storm hits, you basically just have to go out and watch. You can monitor these things on your phone. You can bring up all these graphs and charts on your phone, but it only gives you what's happening at the moment. It can't tell us what's happening, next. So things can change. It can go from like really bad to really good, and you can say, look, it's really bad, I'm going to bed. And trust me, I've made that mistake many times, only to have the whole thing just explode into auroras an hour later. So the best you can do is monitor these graphs and charts to be aware of what's going on, keep in touch, get your email alerts, visit spaceweather.com and just sort of keep in touch with what's going on out there. Watch the charts, and if things start to kick off, the best advice is just to get out there and just spend the night. Monitor the charts and graphs, and don't be put off by the fact it doesn't look like it's happening, because again, an hour down the road and you can have the most amazing auroras. And if you give up too soon, you can be in bed sleeping when it's all cutting loose. And again, I've done that a few times, and it's not a great feeling to get up and see what you missed. And just some of the stuff, some of the research and the sites I researched some of this on. And there'll be a couple more websites coming up in a bit here. And there's basically only three. I mean, this is all the sites I went through to kind of put together all the information that you just saw. But there's basically only three websites that I monitor during storm time.
Jerry,
Mm-hmm.
this is 24 years of the head banging. So this was what year? So we're adding another 11. You're at 35 years now of the head banging. Since
1989, yeah, I built this PowerPoint thing for the last solar cycle for Astronomy Cafe. And so so since 1989, basically. And I'm still gnashing my teeth. They're worn down to nubs now. And that is that for that. And that is actually that was probably October of 2003 from Taylor Beach in Machosen. Big auroras right over the city. That was a good year for sure.
Thank you, Sherry. That's great information.
So that's that. Yeah. So there's a couple of websites now here. How do I share a website?
Just pull it, go to your Chrome or whatever, and what you see is what we'll see.
Okay. Do you have spaceweather.com on your screen?
Mhm.
Yeah.
Okay. So all down the left side of the screen is some pretty accurate information. Basically, it's from ACE, the ACE space satellite I just showed you there. So it gives you all this information, what's happening right now, how many solar flares there's been in the last 6 hours, 24 hours. And it gives you sort of the latest photograph of the sun, and then some information down the side here. How many sunspots there are, how many sunspotless days there have been. So all this information on the left is pretty accurate. It's pretty much real time. And again, the Aurora oval there, current planetary K index, a KP index. So, and as things ramp up, these will all change. So it's a good place to get information at a glance. And here's an interesting thing. You see this map of the US? Everybody see that?
Yep.
Can you guys see that map of the US?
Yep.
So just read above it. That's what happened during the last superstorm a couple of weeks ago. everything, all the shaded red spots, the rocks and soil were actually electrified by the power of that storm. So just read that a little bit, if you can read that there. Electrical currents in the ground, like 10,000 times normal. So I mean, you can see why we need to understand these things. I mean, that's the ground. That's like the dirt under your feet was electrified by the power of that storm. So it wasn't just the the pretty lights and the great looking auroras and stuff. This stuff can have some really, really serious consequences. And you can see just by that there that the very dirt and ground that we walk on was magnetized and electrified by the power of that storm. So this page on spaceweather.com. It's a great resource. I mean, this part, the text here, especially during a storm, they don't tend to update it all that often, so you're kind of left kind of wondering what's going on. But all the information down the left here is pretty good stuff. And so here's the Canadian space weather one, Space Weather Canada. So there's the one this is the thing I was talking about right there. The three different zones, polar, aurora, and subaurora. And you can see down here, so 24-hour forecast, you can click these buttons, so this will scroll through on its own. So 24-hour review, so it'll give you what happened in the last 24 hours. And 6-hour review, so what happened in the last 6 hours. You can see everything changes a bit there. Current conditions, so everything's pretty quiet right now. It'll give you the current conditions, and then it'll give you a 6-hour forecast. That's really handy, especially when a storm is imminent or just started. And those zones, like I said before, those zones will change color depending on how stormy it gets. And there'll be a 24-hour forecast, which is sort of less accurate, kind of like weather forecasts, a little bit less accurate. But the current conditions and the 6-hour forecast are the ones to watch on that one. So saying that if there's one data set, one resource to look at would be those ACE charts. But if there's one web page that ties everything together, it's going to be this one right here. And for some reason, this one takes a while to load. So this is a Space Weather Prediction Center from NOAA. And so the top, so R3 is a radio storm. So obviously there was a solar flare that generated a lot of radio and X-rays and probably disrupted communications a little bit on the ground. So it'll give you the radio interplanetary conditions as well. And there's the G. So G1, G2, G3, G4, G5. So those will change color during a major storm. It'll also tell you what happened previously, currently, and the forecast. And then down here, solar X-ray flux. Not terribly interesting to just a general aurora observer. And there's some solar images from GOES, and this one I think is from LASCO, and there's from SOHO LASCO with the coronal mass ejections. You can click on them to enlarge them. You see the planets right there, and there's Big Dipper up in there, and whatever is occurring right here just went off almost directly either towards us or away from us. It can't differentiate between that, but this is the one you'll watch. This one occurs in real time. It's actually like a movie. You'll see the CME billow away from the sun on that one right there, and you can click on play, and you will get the last few hours of data from it.
Wow.
There's a CME heading in the wrong direction. I believe that one is from the same sunspot complex that caused the last storm. And it's so big, some of these storms are so big that they actually live long enough to make it all the way around the backside of the sun and rotate back into view and cause us more trouble on their second trip around. And what is it, AR 3664 or whatever it was, is coming back around. And if it survives in its current state, that's going to be aimed right directly at us in another couple of weeks.
Apparently they renumber those as they go around.
Yeah. And so here we are again. There's the ACE. And that's the current condition as of right now. So solar wind speed's kind of up and down all over the place. Our speed's tapering off. Density is kind of all over the place. This is pretty chaotic up here. So not much going on really. And then there's the Aurora oval there. Proton electron flux magnetometer. And there's the KP there. So those bars again will turn orange, yellow, red as the storm increases. So everything there. And there's our current sunspot cycle right there. So the one you saw during the PowerPoint one was back here. And here we are today. And this is shaping up to be a much more powerful solar max, as we call it, than the 2014 one was. It was good enough, but this one is shaping up to be a whole lot better. There's more sunspots and they're much stronger this time around. So this, if there's one web page to monitor, this would be the one right here. It's got everything you need, including ACE and all the other graphics to give you this empty box on the right here. I'm not sure why it's empty today, but it actually contains forecast text from NOAA. It might be offline or something, but usually the forecast, the current conditions forecast, is all in text in that box right there. So yeah, you've got your images of the sun, you've got your ACE there. This one here is actually kind of cool because it shows how the there we go. So it actually shows how the CME rotates as it sweeps through space. So there's the one you just saw on the other screen. That's the CME you just saw leaving the sun on the SOHO screen. And it just shows how it rotates through space. This is from the stereo A and B satellites. And this one too, you can click on that and they're all interactive in that you can get them to play a replay of the last 24 hours. This one I think is 24 hours. So you can see how things kind of ebb and flow. And during the storm a couple of weeks ago, that oval was completely red and it was down to Mexico. And I just read that they were actually seeing auroras in New Caledonia and places like in the northern South Pacific. So it was very nearly at the equator.
Wow.
So they're actually considering this one of the superstorms, along with the Carrington event in the 1859 or whenever it was, and that New York Fire Hall one and the Quebec storm. This is actually going to go down as one of the great storms.
So Australia and Fiji must have had fantastic displays too.
Oh yes, absolutely. There were some amazing pictures from Australia, New Zealand, and there actually are well, apparently Hawaii. Some pictures from the Big Island of Hawaii, and yeah, all the way up into very near the equator. So yeah, it was truly a global storm, way down into Mexico, the Caribbean, and Mediterranean, southern Italy. It was just a massive storm. So that's why it's going to kind of go down as one of the great storms in history. So that's Space Weather Agency's dashboard. by NOAA. That's the one page you want to watch because it's got everything. But again, if there's only one chart you want to watch, it's going to be the ACE mag SWAPM, and that gives you all the information that everything else is based on. And that is pretty much all I have. But if you have questions, go ahead.
Anything you want coffee, you would have to be quick because it could be.
Thanks very much, Sherry. Anybody have questions?
Jerry, can you take this prediction back to the May 10th?
To make these predictions here,
Can it go backwards?
on this page here? No, I don't. I've never done that. I know the predictions were way off, like way off.
Oh.
We had 5 or 6 CMEs in a row in the space before May 10th and a few days before May 10th. And what can often happen is you have 1 or 2 that are strong enough and fast enough, but they're coming in at us sort of one ahead of the other. And then what happened, I think, this time is the third one was really powerful, much more powerful, and much faster than the first 2, and it'll catch up and cannibalize them.
Mm. And
then you end up having like a really like an impact much stronger than 1 or 2. Then you get this massive, and that had to be what happened because they were calling for there to be like 5 or 6 separate impacts, and then we got hit with one that was far bigger than any one of those 3 could have possibly caused on its own. And there was one model that was sort of calling for cannibalization. Spaceweather.com, we're kind of just saying, well, we're still waiting for 1 or 2 or something, and maybe there'll be a cannibalization. And that has to be what happened. Because the storms of such magnitude that are seen nearly to the equator aren't just caused by 1 or 2 small little ones. That had to be a cannibalization. So they got it completely wrong. All the models are wrong. Everything was wrong. And it happened in a completely different way. There was some suggestion it was going to be a cannibal, but nobody was really counting on it. And then we got hit with that superstorm. And that's the only thing that would explain that. There's just nothing else would explain why we had such a massive Aurora storm with only a couple little kind of moderate CMEs coming at us. And then the rest of them just seemed to kind of vanish, and that was it. So, the models weren't really accurate. The forecasts weren't really accurate. That's where you just kind of have to wait and see what happens. But I remember that thinking, this storm is way bigger than that. So this had to be at least 2 or possibly 3 combined that hit us all at once. But I don't know how to go back on any of these. I'm sorry.
Well, if they're up in the top right-hand corner, there's archives. Now, where man is right now, it's May 25th. Can you go back to May 10th?
Good
I
idea.
can't see it because I've got images of. Hang on a second.
Yeah, if you just click on 25 and go back to 10. No, right, go down a little bit.
Okay, hang on a sec. There we go. No, I'm sorry. So I've got your images right over that part of the screen.
Oh, right. Yeah, there you go.
There you go. You're there.
Oh, there we go. So let's go back to. So May 10th was the day of the storm, wasn't it? So let's go back to the.
But we would have known about the 7th or 8th, I guess, that something was brewing.
Yeah, because. Yeah, usually like they arrive within 48 hours, usually a little bit sooner than that, usually around 36 hours. Yes.
Yeah, there's a spot that I photographed on Wednesday.
Yeah, so flares just doubled.
Yeah.
So let's see. Let's see what they say on the 8th.
Storm possible on May 11th.
G2 and G3.
Yeah, so and the second CME is following directly behind, and there was about 5 at least in a row. So let's see.
Does that image show what time that was?
Which image there?
This one, where it's showing the CME.
Yeah, there it is.
Is that universal time?
Yes, everything, pretty much everything is universal time, yeah.
Oh,
And May
okay.
8th. That would have been Wednesday, I guess.
But that's only one of them. Again, there was like 5 in a row, so I'm not really sure which one that was.
Right, because your cannibalization thing makes sense, because I'd been watching the sun in H alpha for the several days when this all occurred, building up to, and you could see those coronal mass ejections around that sunspot in H alpha. Because
Yeah.
I know what they look like. They really brighten and turn white, and then it fades.
Yeah.
And then it turns bright white, and then it fades over about an hour's period of time. And I just kept seeing that.
Yeah, again, there was like 5. At one point they said 6, but I'm not sure what happened to them because the first 3 had to be the cannibals. And what happened after that, I don't know, but at some point they were saying there was, let's just see here, hang on. Let's see what they see for the 10th.
No.
Yeah, see, sometimes we do.
G5. 6 CMEs hurled. Yeah. Wow.
Yeah, just one after another over a space of like 3 or 4 days, 2 or 3 days. Yeah.
You also see how fast the planets are moving there.
Oh, yeah.
Venus on the right and Jupiter on the left. Is that it? Is it smaller?
Yeah.
But that's a perfect example of pretty much what we call a full halo CME. So that one I showed you, the PowerPoint one, is kind of lopsided and going off to the side. But these ones you can kind of see that the billowing cloud is pretty much even all the way around. And that's like a full halo that's aimed directly at us. So that's, yeah, and so 2 or 3 of those, it had to be 3 because the first couple were like in the high M class, M8, M9, or very low X class, like X1 or something. Nothing on their own would cause a storm like that. That had to be the cannibal. And either way, it was like possibly the second biggest storm I've ever seen. Biggest one being probably 2003. So that's Victoria, Australia right there. That's from the 10th. And then days after that, pictures kept coming in. They have a real-time Aurora gallery here you can click on. And so people from around the world can submit their things. There was just amazing pictures from just everywhere. So you can scroll through that and go through some of the Aurora galleries they have there. But it's a good page just to kind of, like, I check it every couple of days when it's like quiet times, and then when I know something's starting to cook, then I'll come here at least once or twice a day just to see what's going on, and then I start monitoring the graphs and charts when things are really getting close. And the rest is just practice. I mean, you don't get much practice during the low spot between the solar cycle peaks. So you tend to kind of get a bit lazy over time. Then we start to get close and say, oh yeah, I gotta remember how all this stuff works. And then start monitoring the things. And the rest is just practice, just learning how everything kind of fits together and how the graphs look when storm conditions are happening or imminent, and just seeing how all those charts and the bar graphs and stuff behave, and just doing it over and over and over again, so you kind of get this kind of sixth sense about how it's all going to happen.
Harry, can you go down the page just a little bit more? And there were the graphs below the picture. There you go. So,
Deep grass
well,
here?
just, yeah, so they were showing, no, just that one right there. They were, I just up a little bit, just up a tiny bit. You were showing that the BZ and the,
Yeah.
and how deep the, sorry. Yeah, just, they stay there. Stop. There you go. So the box, around the box in that, where the BZ is, you can see how low they are, right?
Yes. Yeah.
Yeah.
Oh, yeah, it says -40.
Yes.
So it's rescaled. You were showing us before like -10 and things. This is getting.
Yeah, and -10 is where it starts to get good. Especially if it stays there. That's one of the keys. It's not just how much it goes south, but it's how long it stays there. Because I've seen them as it's gone down to -40 and then jumped right back up again, and it just shuts the auroras right off. They just start to form, and then boom, they're gone. So it's got to stay down. So it's much better to have like a -10 or -20 that stays there for hours, rather than a -40 that only stays there for a few minutes and bounces around. And that's how things, they're kind of all interconnected, like the solar wind speed. You can have great auroras with low density and fairly low solar wind speed, but yet a really favorable BZ. And conversely, you can have like just kind of a moderate BZ to -10 or -20, but really strong solar wind speed or really high density. I mean, I've seen the density go up to like 30, 40, 50 protons per cubic centimeter. And so even though the BZ isn't particularly favorable, all the other ones are. So, and then everything in between. So you just have to kind of monitor things and see how it is. But that ACE graph is the key to everything. Everything else you've seen on there is kind of based on that, on those three parameters: the total magnetic field strength, which is the white line, the BT, the BZ, the solar wind speed, and the density. Everything else that you've seen, every other chart, is based on those, basically those four charts, four values. Anything else from anybody?
Brock, I see that Reg has his hand up.
Oh, sorry, Reg. Go ahead.
Okay, first of all, Sherry, I was sitting around the table at Astro Cafe in 2013 when you made your initial presentation. There were about 10 people in the audience back then. And I thank you very much for the much needed refresher course. That was great. I have a question. It seems like on the magnetic fields, there's kind of when the onset, at least on the 2013 event you displayed, there's almost like a steps function the way the magnetic field changes. And I would think that the rate at which that magnetic field changes and arrives would really induce the currents. And I wonder if that's where most of the damage takes place, or is it more to do with the sustained magnetic field that stays elevated for a long period of time?
I would guess probably a bit of both. You could have like a real hit where that the southward turning of the magnetic field may go down to -40, and if there's especially if the density is really high, like the proton density is really high, you could probably have like a real impact and some fairly substantial damage, but fairly quickly. Like I'm not really sure how how these things interact with various types of electronics, just so many different kinds of electronics, but certainly with things like power lines, hydro lines, things like that, there'd be more damage over a more sustained period of time than probably with just a short, sharp impact. So it'd have more time to build up, to gather these protons coming down from above. We would have probably more time to gather them up and funnel them down to the next substation or whatever. But then something to be said for for like a real punch, like a real strong CME impact that has not only high speed and high density, but a really strong southward turning of that VZ. I would expect that would probably do some damage too, but it would be limited because it would be kind of short, sharp, and over.
David, do you got a
it's
question?
very interesting. So thank you very much. I really appreciated it.
Oh, you're more than welcome. No other questions?
David Lee has his hand up.
Yeah, I do. Two comments. I know there are some ham radio operators here tonight. Jim, I see you're on. Do you have any comments about what happened during the storm? Did you detect anything? Okay. Or even Chris Purse, I think you're in the audience as well.
Yeah, I didn't actually try to do anything, so I'm not sure. That should have created some opportunities on some of the bands to get longer distance communications.
You get longer.
Yeah.
Oh, I thought you would just get static.
No.
Okay, so why?
Well, it acts kind of like a mirror. So the stronger that the magnetic field can be, the more reflective it becomes to a radio signal. So if you transmit from here, it often will just drift off, right? And doesn't get reflected. But if it gets reflected, then you can get it coming down thousands of kilometers away.
That's spiff.
That's how that works. So when the sun gets more active, you know, radio conditions improve.
So it increases the ionosphere.
Correct. So therefore,
because it's ions.
For the purposes of radio, you can think of it as being more reflective, if you like.
Yeah.
Wow.
I wonder if Jim is ready now.
He's not muted.
Yeah, I don't know. I'm not sure. Anyways, while we're waiting for Jim, or maybe not, the final comment I made, Sherry, I noticed that you showed a graph of the number of sunspots. So for those of you who are interested, I took a sunspot counting course from AAVSO last year. So it's quite interesting how sunspot counting takes place. And it's on the AAVSO website. You can either take the course formally, or I think the manual for the course is actually online anyway, so you could probably grab it and look at how it's done.
I see Jim has appeared.
Yes.
Oh dear.
Jim, are you there? No. Guess not.
Well,
Rocky, I want to show something on the screen. If
Sure.
Sherry, if you're done.
Sure, yeah, absolutely.
okay. Can you unshare?
You have to unshare, Sherry.
Stop sharing.
Jim here. Am I getting any audio now?
Oh, yeah.
Oh,
I can
there
hear
is.
you now.
Choosing the right microphone is important.
Oh, okay. So Jim, my question for you was, did you notice anything extraordinary about the Aurora in terms of ham radio?
Yes, I did. Actually, for about 4 days, the high frequency shortwave transmissions were just completely shut down. As a matter of fact, a couple of the local radio nets just didn't even bother trying to run their nets for the evening because they weren't receiving anything. Some of the interesting thing about the solar activity, there are two factors involved. One is the ultraviolet and X-ray emissions that ionize the layers in the atmosphere, which act as the reflective layers. And then the other aspect is the geomagnetic field. And what happens there is that the ionized layers are held in position essentially by the geomagnetic field. And when that fluctuates or is disturbed, you wind up with a crinkly layer, which doesn't really reflect radio waves particularly well. or it does, but it basically scatters them more than reflects or refracts them. So
But
that
how does that sound, Jim, when you're listening? Is it a crackling sound, or what happens?
It's a lot of static, a very high level of noise. The crackling and the crashes most often are caused by lightning and electrical discharge in the atmosphere, the lower atmosphere. But for the radio signals, it's just essentially a very high level of noise, a lot of static, a lot of noise, broadband noise, essentially.
Okay.
That BC net is on 80 meters, isn't it, Jim?
That's correct.
Yeah,
That's
so that's a very long wave, right? 80
yes.
meters long.
That's right, and that's about 3.5 to 4 megahertz in frequency. And there are a couple of things that happen actually, as well as that gets into a little more detail. There are multiple layers of ionization in the atmosphere, and the ones that are responsible for the longest range communications are the E layers, echo layers, which are probably about 80 to 100 kilometers up in the atmosphere. But down nearer to the Earth, there's what's called the D layer, and that's a daytime layer because it's so far down in the atmosphere that it's only ionized during the day, whereas the E layers are higher up and they stay ionized throughout the 24-hour period. Now, what will happen is that the radio waves have to penetrate that D layer before they can be reflected by the E layers. And if the D layer gets to be too saturated with ions, then nothing will get through. And so you essentially get a radio blackout so that nothing can be emitted and reach the upper atmosphere where it can be refracted down in further layers. So that's where you get that phrase of radio blackout.
Wow.
Do you know if 17 meters improved at all?
I heard some people had some good luck on that, but I'm not set up for that particular band, so I can't say. I can't say personally, but I do know that some people had some very good luck on 17 and 10 meters, and I do know that some of the data transmission modes were working really well on 50 meters, which is around, I'm sorry, 6 meters, which is around 50 megahertz. That's normally a really short range band.
Well, and some people may have noticed this, because I mean, if you were ever playing around, especially when there were more AM broadcasts, you can often hear San Francisco here at night. And that's a sort of change to which layers are ionized.
That's correct.
Yeah, there's some very powerful radio broadcasts in the United States, and they skip a long way when the conditions change.
That explains something which fascinated me as a child, that at night with a crystal radio, I could get all sorts of places, Idaho and Kansas and so on in Ontario. And during the day, not at all. But now you've answered the question. And thank you very much.
And there's quite an interesting daytime skip on the CB frequencies. So I've got a little one sitting there. Wouldn't transmit very well, but it's a good enough receiver. And I've heard people from Georgia and Alabama and places like that, again, who are broadcasting with about 1,000 watts, which is illegal, but they can make it up here when the conditions are in.
It also affects boat radars too.
Yeah.
Radar.
Yeah. I know I was talking to one guy, he left Halifax in a naval ship and picked up Bermuda.
Well, at least he didn't crash into it.
Yeah. Radio propagation is something of a black art. I know I have VHF radio, which works on the 140 megahertz band, which is just a little bit below the marine band. And in the morning, sometimes I'll check in with a net in Vancouver, and some days it's clear as a bell, and some days it's all I can do to shout into the microphone to make myself heard. And I'm firmly convinced it's something to do with the humidity of the air, because it seems to be relating to what the weather is between here and there. And I do know in the Persian Gulf, a lot of the naval operators were just astounded that they were getting 200 and 300 mile contacts on their marine VHF radios, which technically should be impossible.
Probably more stable air masses.
And something to do with the hot air layers, or the layers of warmed air and humidity over the ocean, I think.
The ship radios used to be very long wavelengths, so that's why, you know, if you see pictures of them sideways on, you see a huge long line going basically over the top of the entire length of the ship. And those are radio antennas for that purpose. And there was a radio facility down, well, we're down in Fairfield, down by Gonzales, that had, I think, 3 or 4 large masts down there, and it could get on the 160 meter band. So you're talking, you know, a wave that is 160 meters long. And those are used over water a lot, or were.
They still use HF shortwave on the naval vessels for long distance communication. And if you look at the side of the frigates, you can see there's a fan of antennas, or fan of wires, about maybe 3 or 4 wires, and that's an HF fan antenna. And they also have a couple of masts that stick out the sides as well. So it's still in use.
Cool.
Thank you.
Any other questions for Sherry?
Let me do my little share.
Okay.
Because I want to say that, as well as those sites that Sherry was talking about, Sherry's Facebook page called Coastal Cats is my main source of information. So for what just happened on the 10th, this was her first post, so it was, you know, more than a day ahead. And then she kept doing these updates. First of now 6 CMEs is impacted. Get ready, North America. This is an extreme event happening right now. I just love these, Sherry. It's really just a great service that you do. And if you're not her Facebook friend, it's really worth it, because you tell people when something's happening.
She does all the work for us.
Yeah. But until today, you were doing codes like G4, KP7, and now we understand a bit better. So that was really very, very helpful.
And I do try and remember to post them on the RASC Victoria Facebook page too. And sometimes I get carried away and I forget completely, but what I normally do is I'll post it on my Facebook page, and then I'll either just copy and paste it directly over to RASC Victoria, or I'll share it. But I do try and share it on RASC Victoria, so you don't necessarily have to be friends with me on Facebook. All you have to do is be on the RASC Victoria Facebook page, and you should see them as well.
That was spectacular, Sherry. Thank you.
Yeah, that was
You're
very,
welcome.
very good.
Thank you very much.
Any questions, just contact me on Facebook, and I'll be happy to clarify anything or whatever you like.
Okay. I know David Lee had some stuff related to Astronomy Day.
Yeah, I do. I think I'll just make the beginner's SIG announcement first, though.
Sure.
So normally we would have the first Tuesday of every month for the beginners SIG, but we have a council meeting on that date. So I'm suggesting, and I will send out a post, I'm suggesting that maybe we'll have our beginners SIG, and we'll talk about whether we'll go over the summer or not. But we'll have that on Monday, so same day today, on June 3rd, actually. So that's what I'm suggesting. I'll send a note out just to remind everybody. Also, along with that SIG, we're probably going to be talking about solstice. And also, I've been sort of alluding to the fact that we might want to do a moonrise sometime. So on the day after solstice, June 21st, there's going to be a very nice moonrise at around 10 o'clock. So I'll send a note out about that as well. So that might be fun to watch the moonrise at 10 o'clock. Okay, so that's the SIG and the announcements for the SIG. And Randy, you wanted me to show the International Astronomy Day promos?
Yes.
Right, so here we go. Oh, and by the way, thank you so much for the people that participated in this. And here we go.
Did you share your sound?
Oh, sorry.
Yeah, while David is setting up, there are different estimates of how many people came, but I think it is safe to say we had about 1,000. There was between 50 and 100 people at any time, which is really good. And I think everybody who was at one of the stations was busy pretty well the whole time. Maybe not the first hour and the last hour, but the rest was all really very active. And, you know, it was one of those many hands makes light work. There was lots and lots of volunteers. We are a very fortunate community to have so many people willing to put on something like this. And I think we had excellent feedback. Lots of kids came, lots of really enthusiastic people. I was just delighted to see the reaction. I think that was a perfect outreach event.
Okay, so here we go.
Are you fascinated by the mysteries of outer space and astronomy? Caught up in a sense of wonder and amazement at the size of the universe? Join us for International Astronomy Day on Saturday, May 18th, 10 a.m. to 3 p.m. at the Royal BC Museum, Victoria. It's free. Throughout the day, we will have 4 excellent speaker presenters to expand your mind. Our 16-year-old recent book author will tell you about our place in the universe. Our local physicist loves and will clearly explain the stars. Our Friends of the Dominion Astrophysical Observatory Vice Chair will share the connection between the night sky and the 100,000 people who traveled the Underground Railroad in the 1800s. And our PhD astrophysics candidate knows how the Milky Way was formed and will easily navigate us through the creation of our spilled milk galaxy. All ages are welcome to attend International Astronomy Day on May 18th, 10 a.m. to 3 p.m. at the Royal BC Museum, Victoria, to explore and appreciate the wonders of our universe.
Have you ever wondered about light? The light we can and cannot see? How light affects us as humans and how it affected the evolution of life on Earth? Most of the light in the universe we cannot even see, but the electromagnetic spectrum reveals the story of our universe. Stop by our responsible lighting display on Astronomy Day for lots of interesting information, including how to help fight urban light pollution and support dark skies.
Hi, I'm David Payne, and I'm excited to invite you to visit the astrophotography display at this year's Astronomy Day celebration at the Royal BC Museum. Astrophotography is a great way to explore and learn about our universe. It combines and develops many technical and creative skills, yet is completely accessible at all skill levels. It is also a very social endeavor, with groups of us from various backgrounds getting together to share our results and techniques so that we have fun and develop together. What I like about astrophotography is that one can start out simple and inexpensively and yet achieve very gratifying results. At the same time, the depth and breadth of skills and knowledge that one can gain is limitless, as the desire to learn and create pulls you in further and further. Some of us like to tinker with and operate highly robotic telescopes, either of our own or the ones available at the Victoria Centre's Observatory. Alternatively, raw images are also available online, or better yet, are available from our publicly traded space and ground-based telescopes available for you to process. We'll have various types of imaging equipment on display and also show how we use computer image processing to tease out of the darkness and pull out fantastic images out of the night sky. So whether you are interested to find out how you can participate in astrophotography, please visit our display and table. It's really a great way to find out about our universe. On the other hand, if you simply want to peruse our results just to contemplate the beauty of the heavens, we would love to show off our images to you. Thanks, and I hope to see you there.
Have you ever wondered if there's something you can look at in the sky during the day? Well, there is. It is the sun. You may look at the sun through a telescope if it's properly filtered or made for that purpose. The telescope on the left, the white one, is a dedicated solar telescope. The only thing it can see is the sun. It uses a special filter that only allows a certain wavelength of red light through into the telescope, and this is the color that is associated with reacting hydrogen. This allows you to see surface details as well as things around the perimeter of the sun, like prominences. It is quite spectacular to look at an active sun through this telescope. The one on the left, the black one, is a regular astronomical telescope, but you'll notice a silver filter at the one end, the objective lens end. This is a solar filter, and it cuts down the light by about 1/10,000th, and that allows you to look through the telescope safely. This allows you to see the sunspots against a more naturally colored background. Again, quite spectacular. So come out to one of our events and have a look through our solar telescopes. You'll be amazed.
So it might be a big telescope, could be a small telescope, could be a medium-sized telescope. There are even telescopes for observing the sun. It's all good to me, it doesn't matter. So if you think you might like to learn more about telescopes and what telescope might be right for you, or if you just want to chat about telescopes, come see me and visit with others of the Greater Victoria astronomical community and learn more about telescopes at the Royal BC Museum on May 18th from 10 until 3, where we celebrate International Astronomy Day.
Great. So thanks again.
That was a great promotion.
David, how long was it from when you decided to start that project till it was posted online?
It took a couple of weeks, I guess. I sort of just planted the seed, and I'm glad people. I originally thought that I was gonna videotape everybody, but it turned out that it wasn't going to happen that way. So Bill actually just sent me a video that he did on his own, so that was perfect. I put some heading areas and footer areas to it and corrected the audio, and I did that for a lot of other people's stuff as well. But it all turned out, it's really good. And I think if I was to do it again, I'd probably do it the same way, because that gives people lots of time to articulate what they want to say, and If it needs to be cleaned up a little bit, I can do that. And people were actually also quite successful just sending me pictures. So I was able to sort of stitch the images together along with their audio, and it turned out quite well.
Now, mine was an example of that because I made the mistake of filming the in portrait mode.
TikTok mode.
Well, so you know, I was holding the camera, I was holding my phone like that and just did it. And so the audio's on that, and then David used still photos to make it into a video. So it did start as a video, it just didn't quite, the wheels fell off along the way.
Yeah, you can see the personalities in the videos as well. So it's good.
Have we posted it for people to see?
I think it's still on the website, isn't it, Joe?
Is if you go to the Astronomy Day webpage, on our website, they're there, and they're also, if you go to the channel on our YouTube channel, they're there as well.
I just ran across it on YouTube without going to the channel.
Yeah.
I didn't actually even mention Astronomy Day because I thought it could just be generically used as we wanted to, as we usually take solar telescopes during the day.
That's a good idea.
Yeah, in fact, you know, I think if people just take pictures at events and things like that, we can always do voiceover later if we wanted to produce something. But yeah, I mean, just keep on taking pictures, and we can always do little short video clips if we need them.
Well, it's spectacular, and we probably should start thinking about using it, you know, something like that to promote the Star Party.
Oh yeah, for sure.
Great. I happen to know that Bill Weir wanted to speak about the Beaveree.
Yeah, I'd like to just like put it out there that as of right now, it's myself and Lauri, because it's always Lauri. And then she'll be booting out of there and probably heading towards the center of the universe for the nighttime. So really, it would be nice if there were, because last year we did it, really, I was just looking at the photos with just 4 people, and it was really manageable. I mean, it's not an insane children's event. They're well-managed children, because the whole scouting rule is when they're at that age, there has to be one adult involved with the group for every 2 kids. So, you know, there's lots of parents there or leaders. So it is an easy event to do. You won't need to bring equipment. I'll be able to bring everything that's needed. Is the banner up at the center of the universe, Lauri? Okay, I'll come by sometime this week and pick it up.
What time should people arrive, Bill?
Well, the thing starts around 10. That's when they will be doing their opening thing. So sort of probably around 10:30-ish, they'll start spreading out around the area. There's a lot of it's just really local little groups setting up little sort of like booths at a fair, and the groups wander around and do what they want to do. So they show up in little bunches, and it's a really quite manageable event.
Bill, you don't need to come down to the center of the universe to get the banner. I can bring it.
Okay.
Don't come all the way in.
Is there a bin of like brochures or something too?
Yep, I can bring a whole bunch of stuff. Yep.
Okay, cool.
Yeah.
And then I'll bring all the scopes that are needed, because in Chris's solar video, a couple of those images were taken with using my little piggyback rig that I showed in my telescope video with the worst iPhone ever made by Apple. So you don't actually need fancy gear to take images of the sun or see it. And so it'll be, if you showed up by 9, it would be easy to find parking. And because we'll be able to squeeze you in. You just say you have gear to drop off, and then we'll find a way to get you
so
close.
The other times I've been there, I've had to park on the side of the road. Is that what the plan is? Or
yeah, but if you remember last year, Lauri, that when you came in, I was able to, there's always these little cubby holes that you can just, you tell them you need to drop off gear, And then you
Alright.
can find a space to sort of squeeze your car in between trees. And you just sort of lie your way in.
Tell everybody where it is.
So it's at Camp Bernard. It's up, you go to the original lights in Souk, right in the downtown, just past the traffic circle. And then you turn right. So it's Otter Point Road. And I'm not really sure how many kilometers down the road is, but it's Young Lake Road. I'm sure at the entrance, it's called Camp
over
Bernard.
2 kilometers from the corner there for sure.
Yeah, I'm in Saanich, and I checked the travel duration. It's just a little over 40 minutes, maybe like 45 minutes.
Probably. And if you do come, I would pack a lunch because
there's no food.
There's no food. It
Be
goes
prepared.
It goes till I think I saw 4 on their website, but you could be out of there sooner than that.
Yeah.
So a couple more people
Come
will be
have fun.
nice.
Yeah.
Bill, I'd be there too.
Well, yeah, you're gonna help them burn pencils.
Yeah.
Bring that set up. The kids really like the burning
They
sticks.
love it.
Showing that
Yeah,
the sun can
burning
light things on fire. Burning sticks. They love that. I'll bring a pack of bamboo skewers.
Lauri, did you want to mention the star parties coming up?
When Bill's finished.
Oh, yeah.
Yeah, so it's, if you showed up by about 9 and you'd be out of there early afternoon.
Yeah, Bill, I just
It's
Googled
fun.
the distance. It's a little over 5K further than I thought from that corner.
Yeah. And then you'd be following the signs. There's signs that
Young
point
Lake
to where
Road.
it goes.
So if
Young
somebody
Lake Road,
wants to
yeah.
come, they should contact you? Or should they just show up?
They should just show up. I'm gonna be there regardless. I'd do it by myself if nobody came.
Well, there's at least 3 people because I'm coming.
Yeah.
So
Okay.
Well, 4 if Alex comes.
That's 4 with Alex. So
there you go.
Yeah.
I'll be there, Bill.
Oh,
okay.
Yay.
There'll be quite a few. Yeah.
Good.
Yeah.
So that's Souk Road to Otter Point Road to Young Lake Road. Pretty straightforward. And you're on Souk Road from the time you're in Colwood. Well, actually,
Yes. Yep.
Just keep going.
Yeah, if you haven't been that way, there's new road that way.
Yeah.
Yeah, the
can really
Oregon
rip
Highway.
for a while.
And you stop for ice cream at the store on the highway where the gas is, and you have really good ice cream afterwards.
So there could be a bit of a delay arriving there then.
No, on the way back.
Oh, on the way back. Oh,
Yes,
okay.
the Esso station, the last gas station just before the Stickleback or whatever it is restaurant, is the cheapest gas in Victoria.
Yes, it's
It's
Shell, isn't it? It's a Shell.
It's an Esso.
Oh,
I
is it?
think it's an Esso.
Good to know.
Okay, I'm done.
Okay, well, Laura, you apparently have some Star Party stuff to mention.
Oh, well, Star Party is it's amazing, but we're already gearing up for another one. June the 1st, Saturday, June the 1st, and it is our presenter comes from Dino Lab, so they're doing a thing on the dinosaurs and things like that, and that's always a really big hit. Lots of people. There'll be lots of kids there, and if it's a nice night, absolutely please come out. Just thank you to everybody that came out for the astronomy day for the evening. There were lots and lots, and what a difference it makes to have people being able to see through telescopes and just chat to people. And there were people with binoculars there, and it got better like we were a little concerned at the very beginning, but in fact people were looking at the moon and having a really good time. By the time the 10 o'clock planetarium show came. Every single person in the planetarium had already been out to see with somebody from the RASC. So that really makes a difference. We really appreciate that. So if it's, if you'd like to come up June the 1st, that's just awesome. Thank you very much.
Lauri, this
Yes.
is the last Astro Cafe. Talk about the whole summer.
Okay, don't just come on January the 1st or June the 1st. It's
telescope
June,
clinic.
June
Telescope
the
clinic.
15th is the telescope clinic, and David's got some people doing that. And again, so we did this before. When was it? October, David? Did we do it October, November?
I don't remember. But...
And we had people bringing up telescopes and asking questions about how to fix them up, or I know people said, I haven't had it out of the box. Can I bring it up? Yes, bring it up, and we'll kind of help out with that. So that's on the 15th. And then starting on the 6th, I believe it's the 6th of July. We're not going to have a star party on that July 1st weekend. So it's kind of the following weekend. And then it's every single week until September the 12th or something like that, I think. So we'll just be going all summer long, and you're all welcome to come anytime up on the hill. Bring your binoculars, and you don't need to have an awful lot of knowledge. You will know more. You seriously will know more than everybody else that you're talking to.
Oh, and we have new smart telescopes too.
And we have 3 new little telescopes that people can put their iPhones up to and take pictures. And we're actually getting a solar filter for it. It's coming. And so they'll have a solar filter, so we'll be able to take pictures right through till like 8 or 9. And so that's going to be fun. Lots of things happening. And I believe we only have one Saturday that we still don't have fully booked for somebody to speak. So I think that's pretty good for all the way through. So got lots of different people coming in. Anyway, thanks everybody for all your support. It's great. Yeah.
And as well as telescopes, we always have a RASC information desk. And what are other things that you need people to volunteer for?
Well, Clinton, Melissa, Tupper are looking after the information desk. I'm hoping people got an email about that. They sent out an email asking for people to help on all the days. That makes a real difference when there's somebody at the welcome desk that's chatting away, and having set out things, handing things out to people. That makes a big difference. So if you've got even one Saturday in the summer that you could man the desk, or woman the desk, as the case may be, that would be really helpful. And it's Clint and Melissa Tupper that are looking after that. And then we have people that are needed outside for sure, and we'll be doing, I think, as David mentioned, we've got these new lovely little telescopes that we do need to have people a little bit trained on as to how, and to be talking to people about using them and things. So if you're interested in that, and Sherry has also agreed to help do some work on the 16-inch and train some people on the 16-inch, so that other people will be able to use that as well. Lots of opportunities to come and use telescopes. Especially if you don't have your own, or you don't want to bring a telescope anywhere, we've got some that you can use. So that would be really great to bring them up. I don't think there's anything else at this point. Thanks, everybody.
Thanks, Lauri. Is there any other news or announcements, or anyone else?
Reg here.
Hi, Reg.
I just wanted to remind people of a zany event that occurs on Thursday, July 4th. It is the Henrietta Leavitt Memorial Horizon Watch, and a number of our rascals go down to a place at Cattle Point, and at 10 o'clock we watch the fireworks shows that start first at Friday Harbor, and then end up at Lopez Island, where they have one of the largest firework displays in Washington State. And not only do you see beautiful lights, you can hear the muffled booms as well. So please join us there. Keep that in mind. That's Thursday, July 4th.
Independence Day.
Okay.
It is Independence Day, but it is also Henrietta Leavitt's birthday. So
That's why they picked it, right?
Yeah. Makes perfect
Even
sense.
though it happened before she was born, but even
How did they know?
I'm going to say a couple of things.
Okay.
So,
Can we move forward a bit, then we can see you on the camera.
okay. Cuts my head off.
Yeah.
Okay.
That's Chris.
Here. This
All right.
Here we go. I'll stand.
Whoop, okay.
Sorry, too close.
So we mentioned it before, but we have our council meeting on June the 4th. So anybody who wants to get involved in the business, and then hopefully it should be quiet on the RASC front to a certain extent until we have our own star party on weekend of August 9th.
Yeah.
Up at St. Stephen's, conveniently close to my place up there. And hopefully this time the weather gods will smile on us up there. It's actually a fabulous spot, but it's just, boy, we just had a couple of, a run of bad luck.
This is the first time that it's in August, not in September, October.
That's right. That's right. And just a couple of other things I want to mention. I want to give a big thank you to Joe over here, who's moved our website over. And this is like a huge event. It's only happened, I think David set up the original website, so long ago, I don't even want to talk about it.
Yeah.
And I'm sure he doesn't either. And then Joe
posted
took
it for
over.
a while, and then Matt posted it, and now we're at a commercial providers. But don't click on it right now because it's down.
Oh, did it die?
We're still going through a few growing pains, but it'll come back, no problem.
I just literally just clicked it just now. I was like, oh, okay. It's not working.
It's down a couple of times, and so we need to get a little stability, but that all happens.
So by the time we get to St. Stephen's in August, we'll be talking about the Saanich Fair, but let's start summer first and then we'll worry about the Saanich Fair later. I want to say, I'm always asked about Hubble, and there's a couple of things I'll say about that. This week is 15 years since the last shuttle mission returned from Hubble. Hubble has been up there on its own for 15 years now, which is incredible, because if it was 15 years without a visit after any other Hubble mission, it would be long dead by now, but it's still going. Now there is a bit of an argument going on about what's gonna happen to Hubble. We have these Dragon spacecraft going up, and there's a private effort called Polaris. They launched a private space mission a couple of years ago with 4 people, and it was all paid for by a billionaire fellow named Isaacson. I've forgotten his first name. And they also were suggesting that they might have a mission to repair Hubble, but it's we haven't heard anything about it, and there's for a couple of years now, and there's a lot of discussion about whether it's going to happen or not. Hubble is still expensive to run, even without shuttle missions. They still spend about $100 million a year to run Hubble, because there's all the infrastructure on Earth. It's still quite a big bill, and they want to spend it on Webb, and of course we have the Nancy Grace Roman telescope coming along. It's passing milestones, and they're talking about shutting down Chandra. It's and this is with these various budget squeezes going on from the larger political turbulence there. But there's going to be a second Polaris mission this summer sometime probably. And it's going to be interesting because they're actually going to have an EVA from this Dragon capsule just on its own. And it's sort of like the old days with Gemini and the early Apollo missions where they have to depressurize the whole capsule and somebody, you know, for anybody to go outside and do an EVA. It's going to be kind of an interesting mission, but, you know, if that mission doesn't go well, you know, that probably will put the final kibosh on any thought for another Hubble repair mission. So be watching it. You know, there'll be some interesting things going on this summer. So that's all I have to say.
Thanks, Chris. Well, if that's everybody, I guess any other last mentions, or are we gonna take a break for the summer?
Well, let me just announce that the next Astro Cafe will be on September 9. And thank you to our set of hosts. So that can I remember everybody's names? Don't bother. I will put it in the newsletter. But we have hosts. So like Brock today, we have Tex, Ken was the setup today, Alex, and I are the two people with the keys. And so it's very good that Alex came on time today because I just arrived just before, but thank you very much. And Kathy is our stalwart coffee maker. And of course, Joe is devoted to making sure that we get a quality video posted often the same evening. So thank you to everybody who makes this. This, I think, was a perfect Astro Cafe tonight. We had lots of interesting content, lots of interesting conversation. And it's the sense of camaraderie that I really, really like. And I look forward to it. And the only way we're going to get our camaraderie now is to see each other on the Saturday nights up at the Center of the Universe and at the Victoria Center Observatory. So when you see requests to go up, do it for selfish reasons. We get to be together because we're not going to get this Monday night together for months and months. So have a great summer, everybody.
Have a great summer. Thanks. Good night.
Thank you.
Yeah. Good night.